we were almost done with number 8 and 9 and got cut off by the video. So we had determined the only excluded values were 0. It's the only thing that can make x or x squared 0 is actually putting 0 in. So we drew our two number lines, and these two problems are identical, so you don't really need to write everything twice. I just put little hoops there. So if it can be any number but 0, the first interval looks like negative infinity to 0, both with parentheses, so 0 is excluded, united 0 to infinity. That one would be the same, and then our set builder would be for all x, such that x is a real number, but x can't equal 0. That's the only thing it cannot equal. So that's the end of domain. So you'll see problems like this 2 more times. Number 1 on your next test, and then again on your final exam. Okay, let's go to page 3. So this is where all the stuff you learned in the last chapter gets kicked into high gear. So look what step number 1 is. And if you look through the packet of notes, guess what step number 1 is on every single problem? Let's see. I think factors, don't see that there. Oh, look at that. Factors, step number 1. You'll see as you look through the packet, every single set of directions say factor. So we have to go through our 8 factoring patterns. I was looking through this and I realized I didn't show my work, so I was starting to show it, and I'm like, oh, I should show it with the students just to remind them. So factor your numerator and denominator and cancel like factors, because anything divided by itself, remember, is 1. That's how we simplify. So what students love to do is start canceling here. We can't cancel things that are added and subtracted. We can only cancel things that are multiplied. So we have to turn it into a multiplication problem so we can go, oh, x plus 4 divided by x plus 4 is 1. And then we can simplify, but we can't cancel things that are added and subtracted. So this is an AC method, so I started working it out here. There's no GCF. Factors of 24 that subtract to 5 are 3 and 8. This says the signs will be different. This says the largest number's plus. So now I have to replace 5x with those two values. So 2x squared minus 3x plus 8x minus 12. And we learned that once you get it into 4 terms, you take out a GCF. So x is common here, and here we have a 4 common, and it's positive because of the sign, so plus 4, 2x minus 3. And that's where I got this from. The next GCF is 2x minus 3, and then we have x plus 4 left over. So I didn't want you to go, how did she get that? Because I left those steps out. Because we're going to learn later that you can kind of guess on these, like what the factors will be, and you can kind of foil around until you get the signs right. So that's how I did it. But we're going to keep practicing this just for a little bit longer until everybody gets really good at it. So that's how the numerator factors. The denominator is a difference of squares. So one sign needs to be plus, one sign minus, and we do square roots. So x plus 4 and x minus 4. And then we see like factors, ding, ding, ding. So that becomes 1. And my simplified version is 2x minus 3 over x minus 4. And I want to show you something, what this compares to, because it's the same thing we would do with a fraction. if you were simplifying, I would go, oh, okay, 2 is 1 times 2, and 6 is 2 times 3. 2 divided by 2 is 1, so I know that 2/6 equals 1/3. So if I have regular fractions, I can simplify them that way too. Usually we just go divided by 2, divided by 2. But by factoring them out and turning them into a multiplication problem like we did here, we can also cancel common factors and get that simplified answer. The same answer we would get by dividing by 2. Divide by 2, 1. Divide by 2, 3. So this works for all fractions, not just rational functions. We could also do it with regular fractions. Factor each one, cancel common factors, write what's left. So it's the same process, just a little bit busier over here. Okay, so we have a fraction here. I'm going to teach you some nice little tricks here with your exponents. So first off, I can see 6 goes into 6 once, 6 goes into 12 2 times. So there's that simplified. And the trick with exponents, do you guys all remember that in division we subtract our exponents? So somebody asked in class once, how do you know which side of the fraction the exponent stays on? Well, it always stays on the side where the larger exponent is. 2 is larger than 1, so I'm going to go 2 minus 1 and keep the x there. Well, on the y, the larger exponent's in the denominator, so I'm going to go y, and I'm going to go 9 minus 5, and it's going to stay down here. So as long as you keep it on the side where the larger exponent is, you just do larger minus smaller. So this z is also going to stay in the denominator because its larger exponent is in the denominator, and I'm going to do 7 minus 3. So yes, if you were making them negative, you would go 2 minus 1, 5 minus 9, 3 minus 7. But we don't want negative exponents. We want to keep them all positive. So the way to keep them positive is leave the base where the larger exponent was, larger's here, and then subtract 2 minus 1. Larger's in the denominator, then subtract 9 minus 5. Larger z's in the denominator, so subtract 7 minus 3. And so that gives us x to the first in the numerator, and we can leave the 1 off. 2 goes in the denominator, and this will be y to the fourth, z to the fourth. And we're done. That way we don't have to deal with the negative exponents because we left the base where the larger exponent already was. So, because a lot of students are like, you told us to write 5 minus 9. Yep, I did. 5 minus 9 is negative 4, but wouldn't that have put it down in the denominator? 3 minus 7 is negative 4. Wouldn't that have put the z down in the denominator? Yes, so I'm just cutting out that middle step by keeping it where the largest exponent is and then subtracting. That way I don't have to move it from top to bottom because it's negative. So practice on that. It's kind of a nice little trick. Okay, so next we have double bubble. How do I know that? Because the leading coefficient's 1. So look at all those double bubbles. 5 double bubbles in a row. So, double bubble, double bubble, and double bubble, double bubble. We love it when they give us double bubble because that's a lot easier than doing all this on every problem, right? Okay, so let's look at the signs. This says the signs are different. Large one's negative. So factors of 10 that subtract to 3 are 5 and 2, and keep the large number negative. So y minus 5, y plus 2. This says the signs are different as well. So y minus, y plus, and this says make the larger number positive. So factors of 35 that differ by 2 would be 5 and 7. And this says make the large number positive. So 7's positive, 5's negative. And look at that, matching factors. We love matching factors. So y minus 5 divided by y minus 5 is 1. Now I can drop the parentheses since there's just one set of factors in each. And there's my answer, y plus 2 over y plus 7. And a lot of students are like, why don't you cancel the y's? I can never, ever, ever cancel things that are added or subtracted. I can only cancel things that are multiplied. So that's why it's okay to do this, but it's not okay to do that. So we only cancel, and if you think back to when you learned fractions, the only time you were allowed to cancel is like cross cancel was when it was multiplication. So don't cancel any other time. Okay? So that is as simple as this answer gets. Okay, on this one we have all positive signs, so that's easy. That makes our life simple, doesn't it? There's no negatives in sight. So we're looking for factors of 48 that add to 14. Would that be 6 and 8? Yep. Factors of 64 that add to 16, 8 and 8. Look at that. Ding, 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 ding. Y plus 8 divided by y plus 8 is 1. So my answer is simply y plus 6 over y plus 8. Okay, it's your turn. We have 3 different types of factoring coming up. So shut off your video and see if you remember these from chapter 4. We can't forget factoring. So try number 13 and number 14 on your own, and then turn the video back on and we'll check them together. Okay, so the top one is double bubble, just like our previous examples. This says the signs will be different. This says the larger number's negative. So let's put in our x plus and our x minus. Factors of 21 that subtract to 4 would be 3 and 7. Make the large number negative, so 7's negative, 3's positive, so my 3 goes here and my 7 goes here. Oh, 4 terms. What do I do with 4 terms? Grouping. So the only thing I know to do with 4 terms is group. So here my GCF is x squared. And I take 2 x's out of each one of these, and I get x minus 7. And then my next GCF is going to be negative 10. Look at the sign. So negative 10 divided by negative 10 is positive 1x. Positive 70 divided by negative 10 is negative 7. And then I can see that's going to be GCF x minus 7 and x squared minus 10. And we can check that. X cubed, yep, minus 10x, yep, minus 7x squared plus 70 looks good. So I'm going to list my x squared minus 10 first and my x minus 7 second, because order doesn't matter. And then I go ding. So x plus 3 over x squared minus 10 is what's left. And remember, no canceling with addition and subtraction, so I know I'm done.